Here we are going to discuss about the parallel axis theorem, and before this we have discussed about the perpendicular axis theorem. So if you don't know, then you can watch that video lecture. And if you don't know anything about the moment of inertia, how do we calculate, what is the meaning of moment of inertia, all those things, then you can watch the previous videos available in the playlist. Okay, let's move on the parallel axis theorem without wasting any time. So this parallel axis theorem is applicable for any kind of body. If you remember the perpendicular axis theorem is applicable only for the 2D or the planar bodies, right? So just for the derivation, I have taken a usual shape of body. This is a 3D body, and some things you need to understand over here because it will not be clear from the diagram. So listen it carefully. I have taken this as a rigid body, and this is the center of mass, this point. Okay, let me use the highlighter. This point is the center of mass, right? And I have taken x-axis and y-axis and z-axis passing through the center of mass, and there is the another axis z1, z2, as you can see in the red line. So that is z1, z2, and I need to find out the moment of inertia about that axis using the moment of inertia of center of mass axis or the z-axis. Okay, so we will derive it. So first let's find out the expression of the moment of inertia about the z-axis which is passing through the center of mass. Okay, and for that what we will do? It is a continuous body, right? And as you know that for a continuous body you need to first take a elemental mass. So I have taken a elemental mass at the point A. The coordinate of the point A are x, y, z. Okay, and if I write down the di up of the center of mass, about the center of mass, that is r square dm, right? And r will be the perpendicular axis from the center of mass axis, and you know very well that if this is z axis and the coordinate are x, y, z, then the perpendicular distance from the z axis will be under root of x square plus y square, right? The perpendicular distance from the z axis is due to only the x and y coordinates, right? We have understood in the perpendicular axis theorem as well, that, right? So dICM can be written down as x, instead of r square I can replace it with x square plus y square dm. And tell me, if I want to calculate ICM, moment of inertia about the center of mass, that will be integration of dICM, that is integration of x square plus y square dm. Okay, so let me write down ICM is integration of x square plus y square dm. Let's keep it as equation 1. Let's call it as equation 1. Okay, now I need to find out the moment of inertia about the z1, z2 axis. Okay, so moment of inertia about z1, z2 axis. And one thing you need to keep in mind that when we are dropping a perpendicular from the z-axis on the z1, z2, then the coordinate which we are getting are a, b, 0. Or you can say that the perpendicular distance between the z and z1, z2. Keep in mind that the z1, z2 and z-axis are parallel, right? So the distance between them will be only due to the x and y coordinates, perpendicular distance. Let me write down the perpendicular distance between z1, z2 and COM axis. Let's call it as d. So d will be the distance between 0, 0, 0 to a, b, 0, and that will be a square plus b square. Let's keep it like this. And now let's try to find out the expression for the moment of inertia about the z1, z2 axis, about this axis. Okay, so for that again I will calculate the the moment of inertia of elemental mass, integrate that. Okay, so let's find out moment of inertia about Z1, Z2 axis, that di will be r square dm, where r will be the perpendicular distance between the elemental mass and the Z1, Z2 axis. Okay, so this distance will be there. If you can watch it, the green line, right? This is a distance. Basically, it will be this coordinate that we are dropping a perpendicular from the Z1, Z2 axis on the A. The coordinate will be something a comma b comma z, and we need to find out the distance between x comma y comma z and a comma b comma z. So that perpendicular distance will be, okay, let me write down. May not be clear to you, so let me write down. We are dropping a perpendicular from a comma b comma z onto the x comma y comma z, so that we can find out the perpendicular distance of the elemental mass. And why we need to find out? Because we need to calculate the dre, right? And in that, r is the perpendicular distance. Okay, yeah. So r can be written down as x minus a whole square plus y minus b whole square. Okay, so di can be written down as x minus a whole square plus y minus b whole square dm. Now you need not to worry how we will integrate it and other things. Anyway, we will eliminate the integration. Okay, let's look. Okay, so I need to find out I about the Z1, Z2 axis, that is integration of di, that is integration of x minus a whole square plus y minus b whole square dm. I think you don't have any doubt till now. You are able to visualize what I am explaining you. Okay, so I is integration of x square plus a square minus 2xa plus y square plus b square minus 2b dm. Very good. Okay, it seems very complicated, isn't it? So let's simplify it. So I is integration of, let's separate x square plus y square. So x square plus y square dm. Now let's separate a square plus b square. So that is a square plus b square dm integration. Now there are two terms, minus 2xa, minus 2yb. Okay, so let's write down them as well. We have minus 2xa dm minus 2 yb dm. Okay, so we have this. Now, do you have something familiar? Do you know something familiar like this? That is equation 1, right? Integration of x square plus y square dm, isn't it? Okay, so let's write it down. I is ICM. Okay, and tell me what is a square plus b square? That is d square. And what is d? D is perpendicular distance between the Z1, Z2 and center of mass axis. So, and that is just a constant, isn't it? Okay, so that is constant. Let's take out from integration dm. And again, we have 2a as a constant, minus 2a x dm minus 2b y dm. Okay. Now, do you know what is the formula to calculate the center of mass? If I ask you what is the center of mass, x coordinate of center of mass of a continuous mass distribution, so then you will say, okay, its center of mass formula is integration of x dm divided by m, isn't it? And similarly, we can find out the y cm. Okay, that is y dm divided by m. Now, can you tell me what are the coordinates of the center of mass? In this in this derivation we have taken the origin as the center of mass. So center of mass is the origin, right? So that is 0, 0. So x center of mass is 0. Okay. So x center of mass is 0. Then I can say that the integration x dm divided by m is 0, which can be written down as integration of x dm is 0. Similarly, I can say from here that integration of y dm is 0. So tell me, this term in the integration will become 0. This term will become 0. Very good. And tell me, what is the integration of the dm? Integration of the dm is complete mass, right? So I can say I is ICM plus md square. This is our final result from the perpendicular axis theorem. We will call it as the perpendicular axis theorem. Okay. Now you need to keep in mind where here in this expression ICM is moment of inertia about center of mass about an axis which is parallel to given axis. And when I say given axis, what is meant by that? The given axis is the axis about which we need to calculate. About which you need to calculate I. And m is the total mass of rigid body. And what is the d? D is the perpendicular distance. Distance between COM axis, center of mass axis, and given axis. Right?